Hi everyone, welcome to Real Science Challenge. I'm Kent Louie, science teacher and talking head, talking about better practices we can do in science education and broadcasting from beautiful Vancouver, Canada, and this is episode 75. And around this time last year, I posted a video titled How I Teach CER in Science in 2022. Now it's been another year, and I wanted to share how I'm teaching CER in science this year in 2023. And long story short, a lot of things I used last year, I still use this year. So check out that video from last year. However, this year, I focused a little bit more time on introducing CER and practicing it before getting students to use it on tests and formal assignments. So when introducing CER, I'm using Ig Nobel Prize winners. And if you don't know what the Ig Nobel Prizes are, I'll tell you in a second. And I'm also having students graph and draw conclusions from sample data from the real world of sports and climate. Now I'll talk a bit more about each in a second, but before I continue, handouts for this episode are available at realsciencechallenge.com/EP75. And please subscribe to our YouTube channel. Now, every year, Ig Nobel Prizes, which is basically parodies of the Nobel Prizes, are awarded to science research that is fun. So for a full list of Ig Nobel Prize winners, you can visit their website, which I'll include in my handouts. So for example, back in 2015, an Ig Nobel Prize was awarded to scientists who studied whether animals of different sizes have different pee rates, whether it took different times for them to pee. Yeah, it's a real study. So to introduce CER, I lead students through the claim, evidence, reasoning framework by using this example, because the study is probably something we've all wondered and could make a prediction about. And of course, at the end of the day, it's a fun example. So first, I state the claim, which I say is the answer to the research question, which in this case is, scientists discovered that mammals over 3 kilograms empty their bladders, that is, they finish peeing in 21 seconds, plus or minus 13 seconds. So that means that an elephant, a horse, or a small dog, all over 3 kilograms in mass, all finish peeing between 8 seconds and 34 seconds. 21 seconds plus or minus 13 seconds. That is their claim. Next, I ask students how scientists got their evidence, which I define as measurements we can observe and record that support the claim. Kids, of course, are going to say, kind of like in an embarrassing, quiet voice, that scientists had to watch animals pee, which is exactly correct. Scientists went to the zoo and filmed 16 animals peeing. And on top of that, they obtained 28 videos from YouTube of animals peeing. And they recorded their data and graphed it right here. As you can see, animals that are 3 kilograms or more, they all seem to take the same amount of time to pee. It's pretty much a very consistent line there, right? As for reasons why large animals and small animals take the same amount of time to pee, students have said that larger animals have larger bladders, which would mean that they have, they put more pressure on the amount of pee they're holding, as opposed to small animals that might have smaller bladders and therefore they don't push their pee out with as much pressure. That is a valid reason. Also, it could also be a survival feature. Animals all need to pee quickly or else they could be eaten or targeted more easily by predators. And another reason could be that larger animals just basically have larger openings and therefore more pee can come out at one time. That is the CER framework right there illustrated in that study. Now, if you don't think that talking about peeing would go over well with your students, then I suggest using other examples. And we have a couple more, one on bee stings and one on fleas, both of which were Ig Nobel Prize winning studies and both of which I've included in my handouts. Now, in the end, the Ig Nobel Prize winners, it's just a fun way to introduce CER. These studies have features of real scientific research and explanations while maintaining some fun in science. Now, another thing I'm doing to introduce CER is getting students to graph some real world data and then writing CER statements using a framework I give them. So for example, I give students this data, which is birth months of professional hockey players in the NHL according to their, birth months basically. And then I ask students to graph this data. And then I ask them this question: what is the relationship between NHL players and the month in which they were born? Explain using the CER, that's claim evidence reasoning framework, right? And then I give them the framework below. So for example, a claim you can start by saying more players in the NHL are born earlier or later in the year, or there is no relationship between NHL players and their birth month. They can start their claim either way. For evidence, they can start by saying according to my evidence or according to the data, this is what I see. And for reasoning, they can start it by saying, more NHL players are born early in the year because whatever, right? Then, on my next quiz or assignment, this is the one I taken for marks, I have students graph this information, which is daily average temperatures by month for 2 different cities. Then I ask them to use that graph and this map to answer the following question. Here's the question: which of the 5 cities on the map do the monthly temperatures on table 1 and 2, right here, correspond to? Use the CER framework as part of your explanation, and I provide the framework below. Of course, using CER gets better with practice, so I'm always trying to find ways to get students to practice while providing that framework. That's it for this episode. Please smash the like or subscribe button or leave a comment below, and handouts once again are at realsciencechallenge.com/EP75. Thanks for watching, and let's talk science education again soon.